Okay. So let's go over section 28, which is solving logarithmic equations. Now you're going to find that logarithmic equations are actually a little more simple than exponential equations. So let's take a look. First, let's go over the steps or processes that are helpful in solving logarithms. So the first way to solve a logarithm is to rewrite that logarithm as an exponential equation. Now there is one other way to solve a logarithm, so let's take a look at that. So the second way to solve these logarithm expressions are if two sides or both sides have logarithms, it is best to write both sides as one logarithm expression. So you have log base something on one side and log base something on the other side. And then let's see. If that is true, then if the whole logarithms are equal, then the insides are going to be equal. Very similar to exponentials. If their bases are equal, then their powers are equal. All right, so let's take a look at some examples using these methods. Really quick though, one thing, and this is very important. You do need to plug your answers back into your function because you need to make sure that your answers are in the domain. So there should be no negatives or zeros inside your logarithm. So we'll go back and check all of our answers here. All right, so if I have log base 4x equals 2, I have one logarithm on the left side and then equals something on the right side. So I'm going to just go and rewrite this as an exponential expression. So log base 4 of 2 means 4 to the second power equals x. So that means that x is equal to 16. And that's it. That's all you do to solve the logarithms. Let's take a look at b. So we have here log base 4 x plus 2 equals 3. So using that same process, I'm going to hook that around and we have 4 cubed equals x plus 2. So x plus 2 equals 64. Subtract the 2 over and we get x is equal to 62. Now let's go and check and make sure that works with our domain. So if I plug x equals 62 back in, it's 62 plus 2 is a positive number. So that solution checks out. You just need to make sure that inside your logarithm you have a positive number, meaning that you cannot have 0 and you cannot have a negative. Okay, so let's say I have 6 plus 2 ln of x. So this is really where one of our first ideas come in that we need to know, and that is that we do need to isolate the logarithm first. So I will subtract the 6, and I have 2 ln of x equals negative 1. Then we need to divide both sides by 2. So we end up with ln of x equals negative 1/2. Now it is okay that it equals a negative 1/2 because remember that a logarithm represents the power. Now my base on this ln is e, so I'm going to hook that around. So x is going to equal e to the negative 1/2 power. Which if I were to go and plug that back into my original equation, ln of e to the negative 1/2, that is okay because it's a positive number. So that is our answer. So this next one's a little bit trickier. We have log of x plus log of x plus 15 equals 2. So we want to rewrite these as one logarithm expression. So since I am adding, I can rewrite that as multiplication. So now I have one logarithm and my base is 10. So I've got 10 squared equals x times x plus 15. So 100 equals x squared plus 15x. Let's subtract the 100. And we're going to solve this quadratic equation. So we'll need to factor 100 is 10 and 10, that's not 15. How about 5 and 20? And there it is. So we've got x plus 20, x minus 5. So that means that my two solutions for x are negative 20 and 5. Now it is very important that we go and check our answers. So if I were to plug negative 20 into my first equation, I get log of negative 20. And you cannot do that. So that doesn't work. Negative 20 is not a solution. If I plug 5 in, log of 5 works, and 5 plus 15 is 20, so log of 20 works. So my answer is only x equals 5. Once again, it is very important that you remember that the domain of logarithmic expressions is greater than 0, meaning you cannot have a number that is negative inside your logarithms. You can have your whole logarithm equal and negative, but inside, as well as your base, cannot be negative. Now this problem is going to follow kind of the same pattern. So I have log 5x plus 3 equals 1 minus log base 5x plus 1. Now whenever we can, we want addition, which relates to multiplication, not division, or subtraction, which relates to division. So what I'm going to do is I'm going to add over that other log base 5. So I have log base 5x plus 3 plus log base 5 x minus 1 is equal to 1. Now I will rewrite this group on the left side as one logarithm because they have the same base. So we end up with log base 5x plus 3 times x minus 1 is equal to 1. Okay, let's rewrite this as one logarithm, or as an exponential equation, sorry. So I have 5 to the first is equal to x plus 3 times x minus 1. All right, in order to solve this equation, what we need to do is FOIL through first. So we've got x squared plus 2x minus 3. Let's subtract the 5 over. X squared plus 2x minus 8. And then, of course, we need to factor this. So we've got x plus 4, x minus 2. So my two values for x are either x equals negative 4 or x equals 2. We need to just go and plug these back into the original equation to make sure that your domain is not restricted with those values. So if I were to plug 2 in, 2 plus 3 is 5, and you can take the log base 5 of 5. 2 minus 1 is 1, and you can do log base 5 of 1. So 2 checks out. It is in fact a solution. Now let's try negative 4. So negative 4 plus 3 is negative 1. Can I do log base 5 of negative 1? Absolutely not. So our only solution is x equals 2. So log base 2x plus 2 minus log base 2x minus 5 is equal to 3. So let's rewrite this as one logarithmic expression here. So I end up with log base 2. Because they are being subtracted, we're going to bring them together using division. and that will equal 3. Now, it is good if you have a mix of logarithms and constants, that all the logarithms go onto one side and then you combine them into one logarithm. If you just have logarithms on both sides and no constants, then it's easier just to write as one logarithm. But let's take a look here. So I'm going to rewrite this as an exponential equation. So we have 2 to the third power is equal to x plus 2 over x minus 5. So a couple ways we can solve this. If we just multiply both sides by the common denominator, which is x minus 5, cancels out there, and we are left with 8x minus 40 is equal to x plus 2. So subtract the x over, it's 7x. Add the 40 to the right side, we get 42. So we get x is equal to 6. Let's go and double check and make sure that we can plug that 6 into the equations. So we have x plus 2, so 6 plus 2 is 8, that works. And 6 minus 5 is 1, so that works there. So x equals 6 is not restricted in my domains, so we've got our solution. Alright, so log 2x minus 6 plus log 2x minus 4 minus log 2x equals 2. What on earth? This is a very long problem. But like I said, you want to have everything with the logarithm on one side and the constants onto the other side. If you have any constants, that's the case. So they all are base 2. That makes us happy. We're going to go and rewrite this as one logarithm then. Log base 2. I have x minus 6 plus the 4, so that means multiplying x minus 4, all divided by x equals 2. So there's our logarithm. Now we just need to rewrite it as an exponential expression. So 2 squared is equal to x minus 6 times x minus 4 all over x. Okay, the easiest thing to do here is multiply both sides by x. Oops, sorry. That does not want to work. Okay, there we go. So we've got 4x is equal to x minus 6 times x minus 4. Okay, let's go ahead and distribute through this side of the equation. So we end up with x squared minus 10x plus 24 equals 4x. So let's subtract the 4x over, and we get x squared minus 10, sorry, not 10, minus 14x plus 24. And we get to factor that. So we've got x minus 12 times x minus 2 equals 0. So that means that x will be 12 and 2. Alright, so those are our possible solutions. We just need to make sure that they work in the domain. So if I plug 12 in, 12 minus 6 is positive, 12 minus 4 is positive, and just 12 is positive. So the 12 checks out. Now let's look at the 2. 2 minus 6 is negative 4. Right there. We do not have a solution, so my final answer is only that x is equal to 12. Now, it is possible that both solutions could work. It is possible that only one solution could work, and it is even possible that neither one of the solutions can work. So it is important to check both solutions. All right, this equation is a little bit different. Because I have no constants here, The easiest thing to do to solve this problem is you have a logarithm on this side and a logarithm on this side, and they all have the same bases. So I want to first rewrite the right side so that we have one logarithm. So that would be 4 times x because they are being added. So the rule says if you have a logarithm with the same base and the two sides are equal to each other, then the insides are equal. And we solve this equation. 4 equals 3x, so x equals 4/3. And let's just go make sure that it keeps the insides of all the logarithms positive. It does, so we're good. So our final answer of that is just x equals 4/3. Now let's look at the very last problem here. I have ln of x plus 4 plus ln of x plus 1 equals ln of x plus 8. And since there are no constants all by themselves here, meaning added or subtracted constants, you can rewrite these as one logarithm. So what we've got here is we need to rewrite this as ln x plus 4 times x plus 1 equals ln of x plus 8. And since both sides have the same logarithm with the same base, it's like you're canceling both sides out and you're left with x plus 4 times x plus 1 equals x plus 8. Now we need to solve this equation by foiling. So that's x squared plus 5x plus 4 equals x plus 8. We're going to subtract over. So we have x squared plus 4x minus 4. Oh boy, that does not look good. If that were a plus 4, we would be very happy, but it's not. So what we are going to do is we have to use the quadratic formula. So I readjusted my page for the space on this. So we've got here negative b plus or minus the square root of b squared, so that's 16, minus 4 times a times c all over 2 times your a. Those are going to be my values for x. Oh my goodness. So we have x. There we go. The screen kind of wanted to not do what I wanted it to. So we have negative 4 plus or minus the square root of negative 4 times negative 4 is plus 16, so it's 16 plus 16 all over 2. So that means here x is equal to negative 4 plus or minus 32 is 16 times 2, so we have 4 square root of 2. So that means that x is going to equal negative 2 plus or minus 2 square root of 2. And those are actually not my answers yet. I need to go and make sure which ones work and which ones do not. So I would plug these into a calculator to get about what they are. But the negative 2 minus 2 square root of 2, that is going to be a negative number. In fact, it's a negative number that's around 3, 4, let's see, about 5. So it's around negative 5. So if I go negative 5 plus 4, that becomes negative. So that one does not work. Now if I go negative 2 plus 2 square root of 2, I said the square root of 2 in my head is about 1.5. 1.5 times 2 is 3. Negative, it's a little more than 3. So this one, if I plug into 4, will be positive still. If I plug it into 1, it will barely be positive. And if I plug it into x plus 8, it is positive. So My only solution here is -2 plus 2 square root of 2. So not the most fun process, but do use your calculator to check. There's no harm in that. Alright, so that is it for solving logarithmic equations. The hardest it gets is having to use the quadratic formula.